All right, here we go with our second video for Algebra 2 Honors, Unit 3, Lesson number 2. So we will make it through this video. We probably won't get to everything in this lesson or in this second part of the lesson, but we'll just carry it over into our next class period. But again, we will be able to finish the video at least. So let's go ahead and hop right into this here. All right, so we've got sneakerhead Carlos, and we've got his weekly revenue, and he's going to hire a distributor. So business is booming if he's going to hire a distributor, and it's going to cost him. And we want to see what values of P are his price. He wants to still remain profitable, of course, even with the distributor. And then what value will maximize the profit. So let's go ahead and start off with some basic business here, that revenue minus cost equals profit. So he's going to make a certain amount of money, but then he's got to spend money, or his cost. And then once you subtract that cost, that will be his profit. All right, so we're going to use system of equations to find values for the price P. So knowing we've got revenue minus cost equals our profit, and let's just say profit is Y. Well, no, let's just go ahead and say we've got Y is going to equal our revenue, negative P squared plus 30P, minus our cost, which is 4P plus 25. Now let's go ahead and do some simplifying here. That's going to equal negative P squared plus 30P, distribute a negative 1, that's minus 4P minus 25. So we can combine our like terms. That's going to equal negative P squared plus 26P minus 25. So our revenue minus our cost, we see we can model it as this one quadratic function. And let's go ahead and still look at the fact that we've got this situation right here. We're going to have a maximum because we have a negative leading coefficient. And let's see, I don't want that negative right here. So what I can do is say, let's multiply through by negative 1. So I get P squared minus 26P plus 25. And if I want to make a profit, that means I want this to be greater than 0. So I want to see what is going to make it equal 0. Now we can do quadratic, whatever, we can try discriminant. But again, the first thing I want to do is look at this and see, can I factor this? Yes, I can. P minus 1 and P minus 25 equals 0. And I'm not going to go through the intermediate step. I'm just going to go ahead and say P equals 1 and P equals 25. So here's when P equals 1 and P equals 25. All right, so that answers part A. All right, so we're going, and I'm going to just abbreviate and say we've got a profit if 1 is less than or equal to the price, less than or equal to 25. It doesn't say the price is in dollars or what. I mean, we can assume, yeah. But anyway, so we want to get used to answering these in full sentences. So we're going to be profitable. We see if it's less than 1, we're not making money. If it's greater than 25, we're not making money. So from 1 to 25. All right, now part B. So I'll just box that for part A. Now for part B, what value of P will maximize the profit? And again, we've got P and we've got R. All right, so revenue is our vertical axis. P, our price, is our horizontal axis. And we can take advantage of the fact that we know our x-intercepts are at 1 and 25. So our axis of symmetry, which is where our maximum value is going to be, because that's going to be our vertex, is midway in between there. So 1 to 25, that's a difference of 24. So that means we're 12 away from 1, 12 away from 25. And so a value of P equals 13 will maximize the profit. and that is for part B. See? Okay. All right, let's keep it moving then. And look at our next one here. A rocket launched from the ground follows a parabolic path, okay? So it's launched from the ground, y-intercept is 0. It's going to look something like that. And at the same time, a flare is launched from a height of 10 feet. And it follows y equals negative x plus 10. Will they hit? And if they do, at what height? Looking at what we have here, and we've just got classic x and y this time. And we have y equals negative x squared plus 10x and y equals negative x plus 10. So if they hit, all right, that means their paths cross at exactly the same time, same height at the same time. So we're looking at y equaling y. They will hit when negative x squared plus 10x equals negative x plus 10. So let's go ahead, add x and subtract 10 from each side. And that gives us negative x squared plus 11x minus 10 equals 0. And once again, now that I've got this modeled as one quadratic, I don't like that leading negative. So I can multiply through by -1. I always want to explain, verbalize what I'm doing here, not just switching things. It's not magic. So x squared minus 11x plus 10 equals 0. And at this point, we can do our discriminant. And if our discriminant is not a negative number, then they do hit. But looking at this, I see, hey, I can factor this. X minus 1 and x minus 10 equals 0. So x equals 1 and x equals 10. It says, will they hit and at what height? Now, I don't really like the way this is worded because according to this, they will hit when x equals 1 and when x equals 10. And let's think about why that doesn't make a whole lot of sense. Something like that. If a rocket and a flare hit right here, they're not going to hit again because they're going to knock each other off the path. And that rocket, I don't know what size that rocket is, but maybe the rocket will disintegrate the flare when they hit or something. But anyway, this is fine as a math problem, but I'm thinking more on a physics and actual what would actually happen. If they hit the first time, they will not hit again. But anyway, let's ignore that. At what height will they hit? So that means the first part is just yes, they will hit. And at what height? So they're going to hit when x equals 1 and when x equals 10. So they're going to hit when y equals negative 1 plus 10 and when y equals negative 10 plus 10. So that equals 9. And we're talking about feet, okay? And when y equals 0. So they will hit at what height? They will hit at 9 feet. Yes, they will hit. I'll just add the answer onto here. At 9 feet, at a height of 9 feet. Oops. And 0. And I need to put height. They will hit at a height of 9 feet, and they will hit again at the ground. All right, so the sketch doesn't quite match that, but that's okay. It's just a sketch. All right, now, keeping it moving. We have a daredevil jumping off the CN Tower. He falls freely and then releases his parachute. So his free fall has this parabolic motion. And under the parachute, we've got a straight line linear motion. So how long after jumping did he release the parachute? Well, going off what we're looking at here, again, we're looking at when these two are equal. And just to point out, so the CN Tower, he's jumping from a height of 360 meters. Ooh, that's way up, 360 meters. Okay, almost a quarter of a mile up. So we're looking at how long, and we're looking at a function of t, height as a function of t. So he jumps from this height and follows a parabolic motion, and then he releases his parachute and follows a linear motion, and we're looking at height as a function of time. So we want these to be equal. We're looking at negative 4.9 t squared plus t plus 360 equaling negative 4t plus 142. All right, so pretty sure you know what to do starting off here. We want this to be set equal to 0 so we can model it as one quadratic. So we're going to add 4t and subtract 142. So that we get negative 4.9 t squared plus 40 plus, no wait, plus 5t. Made it look like a 42. Go ahead, correct that. Plus 5t plus 218, that equals 0. And now let's go ahead. We're going to have to solve for our discriminant, so let's just do our discriminant anyway. All right, so we're looking at b squared, and I'm just going to say 25 minus 4, negative 4.9 times 218. It doesn't look like a 2. So that means we're looking at 25 plus 4 times 4.9 times 218. So we have 4297.8. And that is a terminating decimal. We're not rounding off. That is an actual full answer, a terminating decimal. So we do 4297.8. So solving our quadratic, we're going to have t is going to equal negative 5 plus or minus the square root of 4297.8 divided by, and I'm just going to go ahead and put negative 9.8, 2 times a. Now, this is definitely going to be a positive number. So let's go and understand again, if we do negative 5 plus this rather large positive number, we're going to get a positive number divided by negative 9.8. That's going to give us a negative time. A negative time makes no sense. You can't have a negative time. So that means we only need to look at negative 5 minus the square root 4297.8 divided by negative 9.8. So we have negative 5. Now go ahead and put it in this way. Negative 5 minus the square root 4297.8. And that, oh no, put my parentheses outside. There we go. And that divided by negative 9.8. And so we see that is approximately 7.2 seconds. So we released parachute. SEC. All right, so the Daredevil, he released his parachute approximately 7.2 seconds after jumping, would be the full, complete sentence way to write that. All right, last one. Looking at our systems of equation, we have a punter kicking a football, and we have that height there, everything, and a blocker is coming in with his hand up. And can the blocker block the punt or knock it down? Okay, can the blocker knock it down? And if so, when will that happen? So we're looking at when will these two heights be equal? Because again, we're looking at, I want to keep reinforcing this, we're looking at height versus time. I know we are used to seeing y as a function of x, but x only refers to the horizontal axis. That horizontal axis, as we've seen, can be time, it can be price, it can be different things. We want to get used to that. So h as a function of t, and each of these could be written h of t. All right. When will these two be equal? So we've got negative 4.9 t squared plus 18.24 t, 18.24. Can you see that decimal? (18.24t) plus 0.8. When we got that equaling negative 1.43t plus 4.26. All right, starting to get a little sloppy here. So we're going to add 1.43t and we're going to subtract 4.26. Giving us negative 4.9 t squared plus 19.67 t minus 3.46 equals 0. Now, can the blocker knock down the punt? Well, let's see. We need to check out our discriminant. So we're checking out 19.67 squared minus 4 times negative 4.9 times a negative 3.46. And I already have an idea for the answer. Okay, so let's look at this. We got 19.67 squared minus 4 times a negative 4.9. So that's negative times a negative becomes a positive, times another negative, so that goes back to negative, but I'm pretty sure 19.67 squared is going to be larger than all that. Negative 3.46. And indeed, we have a positive number, so he can block the kick, or he can knock down the kick. Now let's go ahead and say, well, let's go back to this here. So that equals 319, what was it, 319.03, 0929. Make sure I wrote down the correct number here. 0929, okay. All right, and now completing our quadratic, we're looking at negative 19.67 plus or minus the square root 319.09 divided by 2. No, we're just going to go ahead and say divided by negative 9.8. Now let's look at this here. 20 squared, all right, this is why we need to know our perfect squares. 19 squared is 361. So this number here is going to be smaller than 1967. So if we subtract this, we're going to end up with a more negative number. So we're going to have a negative divided by a negative. But also, if we add it, we're still going to end up with a negative number. So this gives us negative 19.67 plus or minus. And now, remembering what I said about waiting until the end to round off our numbers, we can take this number and, let's see, work a little bit of magic here. If I raise this to the 1/2 power, that's the same thing as taking the square root. So I'm going to raise that to the 1/2 power. So 17.863. So let's remember 17.863. And what I want to do now is go ahead and model this in Desmos. So we've got negative 4.9, and we got to put in x instead of t, x squared plus 1967 x minus 3.46. And we got 0.184 and 3.83. So let's look at that. We've got 0.18 and 3.83 seconds. So technically, what we're looking at here, if we look, the kick, we've got 0.8, so it's the ball is being launched from 0.8 meters above the ground. And the blocker's hand is coming in at 4.26 meters. What? Wow, that doesn't make sense. Okay, but anyway, modeled by got to remember, it's modeled by that equation. So it's modeled to say we're up here. Now we're looking at kind of like with our question about the flare and the rocket. If he hits the punt right here, he's not going to hit it again right here. So this answer is what's called a superfluous solution. It solves the equation, but it doesn't make sense in the real world because it can't happen. So he can knock down the punt, and it will happen at 0.18 seconds. All right. Again, 3.83 seconds. By that time, the return man is about to catch the punt. So it hits at 0.18 seconds. All right. So there we have it with our video 2 for lesson number 2, looking at systems of equations, modeling real-world systems of equations that are nonlinear. All right, and we're done.